So DHCP, dynamic host configuration protocol. And yeah, so DHCP, dynamic host configuration protocol. Why do we need this protocol? For suppose if we are having STP, we need this to avoid layer 2 loops. If you are going for whatever the routing protocols, those are for exchanging the information dynamically. Everything has a purpose. And why do we need DHCP? It must have, it should also must have an purpose, right? And DHCP, dynamic host configuration protocol, is to configure host dynamically. Now the question is, what will we configure on host? First thing, whoever the host might be, whatever the PC you have, PC, mobiles, laptops, servers, if they need to communicate with the network, you need to do a very basic configuration. That is IP address, subnet mask, gateway, default gateway, right? And if DNS, then who is a DNS server? Address. These are some very basic configurations we need to do in order to make a host connect to the network. There. Now, why do we need to do it dynamically? Why cannot we do it manually? Requirement is, if we are having 1 to 10 pieces, we can do it. 1 to 10 hosts, that's not a big deal. We have got very less number of PCs or hosts that we need to be configuring. So we can do it manually. But what if you are having 100 to 200 pieces? How many pieces will you keep on configuring daily? Right? So first thing, we need this DHCP when a huge number of hosts are existing in your network. Okay, let us think that that's not a big deal, we will do it. Okay, bro, good to go. A very big major problem is manual errors, human errors, we call it as human errors, right? So if you are configuring 100 pieces, it may prone to many errors. Why? Because we are humans, we are born to make errors. So we can give a single IP address on multiple devices. We may forget it. We are not that intelligent, right? In memory point of view, we are not that intelligent. Logically, we are very intelligent, but in memory point of view, we are not, right? So we may prone to many errors. In order to avoid those errors, we need DHCP. Okay. Now, third one is records. If we are configuring the devices, like if we are giving IP addresses on 100 pieces, we have to maintain a record which PC has got what IP address, such that whenever we are troubleshooting, it will be easy for us, right? But in order to maintain these records, again, we have to manually write these records. We have to make a sheet on what PC number or what PC with what MAC address we have given what IP address. We have to maintain a record. It is again an overhead, right? So in order to avoid these three major problems, we have come up with DHCP, which is Dynamic Host Configuration Protocol. right? So what will he do is, on behalf of us, he will assign the MAC IP address to devices. Okay, he will do it for whatever the number of addresses, until and unless he is having IP addresses in his in his pool, right? First thing. Second thing, he can do it within seconds. If you are manually giving the IP address on a device or multiple devices, some hundreds of devices, it minimum takes some hours, at least 1 to 2 hours. What if you are a rapid worker, even though it takes you minimum 1 hour? But if you are going for DHCP, it will do it within 2 seconds. No matter whatever. Within 2 to 3 seconds, it will configure hundreds of devices. So time saving. So it assigned the addresses, it assigned within seconds, first thing. Second thing, there will be no errors. Being a machine, he will never do errors. Until and unless you configure something wrong, it will never do errors. Third thing, it will maintain a record that to which host, to which MAC address, what IP address is assigned. It will maintain a record. And that record, we call it as DHCP binding table, or bindings in short, DHCP bindings. Right? So this is why we have come up with DHCP. Very basic, right? But along with this, if you are going in depth for DHCP, and if you are studying the RFC of the DHCP, you can also see that along with this basic configuration, even my DHCP server can load the operating system on my PC. Okay, but that is very advanced level. Right? So how does the DHCP server assign this IP address? What is the procedure? What is the process it follows? Let's see now. DHCP dynamic host configuration protocol. It is an application layer protocol, which means it works at layer 7. And remember, being a layer 7 protocol, it will have two things in common. One is which layer 4 protocol, and what is the port number on which it is listening on. So layer 4 protocol is UDP, and the port number it listens is, actually it uses 67 and 68, but it listens on port number 67. Okay, DHCP server listens on port number 67 and client uses port number 68. So in total, DHCP uses 67 and 68 two port numbers. And it uses DORA process. Okay, see, it is called as DORA process, but actually it is not the process. These are actually the messages exchanged by the DHCP server and client in the process of getting the IP address or assigning the IP address. Right, so what is this DORA? Discover. Discover, it is the first message sent by client to the server. Right? So discover is the first message, and out of this DORA, DORA, D is the first letter, and that D represents discover. Right? So it is the first message sent by the client, and it is the first message in the DHCP process. Right? So this is the message sent by the client, actually this packet is intended to the server, intended to reach server, but sent on 255, 255, 255, 255 broadcast. Right? Why? Because my client, he don't even have an IP address. So how can he send an unicast packet? He can send a unicast packet if and only if he has an IP address, and if and only if he knows who is the DHCP server. Right? So when he don't even have an IP address, how can we configure a DHCP server on him? And that is why he cannot send an unicast packet, so he will send a broadcast packet, and that packet is encapsulated in UDP, sorry, sent on 255, 255, 255, and it contains UDP payload with port number 68 as source and 67 as destination. Clear? So actually this packet is sent for two reasons by the discover. The meaning of this discover packet is client sending a message, or he's asking, or he's shouting in the network, is there any DHCP server in the network? That's the meaning of this particular packet. Right? So if there is an intended server in the in that environment, he will listen on this message and he will understand that yes, here is a client who has no IP address. I need to send an IP address. Right? So from the client point of view, client is shouting for the DHCP server, and from the DHCP server point of view, he is listening on this message and he understands that there is a client who has no IP address to communicate. And in reply to this, server generates a message, and that message is your offer, and it is the response message by DHCP server to client. To client, right? And it is again sent on 255, 255, 255, 255 with some IP address in the UDP payload. So in offer, what does DHCP server do is he will send a message. He will send a message offer, and in that offer he will send the IP address that he wants to assign to that particular client. And remember, this is an offer, it is not a rule. DHCP server is offering this particular IP address to the client. Now it is up to client whether will he accept that IP address or he will not. That is up to him. And again, remember, this packet is broadcast again. Okay. And if you go in detail, there are again, this can be again a unicast or broadcast, right? But remember, as of now, this is broadcast, right? Now, in response to this, client will generate the packet from his side, that is request. It is the message sent by client in order to request the address. Now, what does this request means? In offer, he has received an IP address. right? But DHCP is still thinking that DHCP server is thinking that I have offered him, but I have to receive an acknowledgement from the client that he's okay with that IP address, right? So request is a message which client will tell the DHCP server that he's okay with this particular address. So he requests an address, he requests the DHCP server to allocate him that particular IP address which he has received in the offer. And it is also sent on to 55, 55 to 55, 55. And now acknowledgement. This is the packet or message sent by DHCP server to acknowledge client that he has allocated the IP address to him. So it is an acknowledgement that remember, until and unless client receives an acknowledgement for that particular IP address, he will not use that IP address, right? So once he receives an acknowledgement, then only client or host is eligible to use that particular IP address for him. So this thing DHCP server knows, so he will send this acknowledgement and he will make this entry in his records that he has assigned this particular IP address to this particular MAC address. This is your DORA process. Have you got, guys? Hello?
Yes, sir. Yes, sir.
This is your DHCP process, which is called as DORA, which are actually the messages: discover, offer, request, acknowledgement. Right? So discover is client shouting for the DHCP server to identify who is the DHCP server and requesting him the address. Offer is the address, is the message sent by the server towards a client offering him an IP address, but he has not yet assigned him. Now now DHCP server will expect and request in order to make sure that client is happy with that IP address. So now client will initiate a request towards the DHCP server telling that he is okay with that IP address. Now acknowledgement, the DHCP server will acknowledge him that yes, he has allocated that IP address to him. So these are the 4 important messages that are exchanged between the server and the client in the process of allocating the IP address. These messages are very important, so you need to remember this.
Okay, sir.
Yeah, DHCP DORA process, right? And using DHCP, we have no administrative overhead. We no need to maintain any records, no human errors, and the configuration will be faster than a human does. Right? And that is why we use DHCP instead of doing it statically. And then we have DHCP options. DHCP options are actually some extra information that whether DHCP server or DHCP client needs to request the information to allocate the IP address from DHCP server point of view, and from client point of view to request some information. Right? For example, from DHCP server point of view, if he cannot identify the client or if he cannot identify from which network is he. So what will he do is he will request some extra information in the form of options, right? And from client point of view, if client by default receives IP, subnet mask, gateway, and a DNS server. But if he needs an IP address of TFTP server, how can he request that? So he will request that in option, right? He will set this option bit set 1 and he will send it. And whenever DHCP server receives it, he will check, yes, he needs this information, so he will give that information to the client, right? So it is nothing, just requesting some extra information.